All right, hope everybody had a good weekend. So today we are going to talk about integrals with ln, and then we are done with our integrals in E unit. So next time we will just have a review summary worksheet that is taken the place of our test, and we're going to call it good. So today, though, we are looking at our final thing, which is the integrals of natural logs. Okay. So last week, maybe the week before, we learned that the derivative of ln x is 1 over x, okay? Therefore, the integral of 1 over x is ln x, okay? Last time that we did something, we looked at integrals that had e's in them already, all right? We are never going to do an integral that has an ln in it already because it's just too complicated. All right, so we're not going to worry about that. So we're going to start with things in the form of 1 over x and end up with a natural log. Okay? So let's look at our first example, number 1. So if I want to get this to look like 1 over x, the first thing I'm going to do is take out that 4. Okay? All right. And then the integral of 1 over x is ln x. So this is just 4 times the ln x plus c. Remember your plus c every single time that you don't have anything up here and here. Okay? Let's look at this one. All right, so this one we're going to need to break into 3 different integrals. So this is negative 3 on the integral of x, minus the integral of 2x to the 4th, plus the integral of 2x. Okay, so that's going to be, whoa, that's 1 over x, isn't it? Okay, so that's going to be negative 3 ln x minus, okay, raise and divide, so that's 2/5 x to the 5th, plus raise and divide, that's just going to be x squared, plus c. Okay, so the takeaway from those first 2 examples is that if I just have the integral of 1 over x, that's going to be ln x. All right, so moving on, of course, it's not always going to be that easy. Okay, just like exponential functions, we're going to have to more often than not do substitutions. Okay, u is always going to be the thing that's on the bottom. Okay, so here we go. When I look at this, I see that the bottom has a power that's 1 more than the top. Okay, the bottom has a power that's 1 more than the top. That's how I know this is going to be an ln. Okay, and I'm going to need to let u equal x cubed plus 5. So then du is 3x squared dx. Okay. All right. So if I'm going to fix that top, I already have the x squared. Okay, but I need a 3. So I'm going to take out the negative 6. All right, and then I need a 3 up top, so I'm going to divide by a 3 on the outside to counteract it. All right, so now I'm ready to substitute because I've fixed my du, so that's negative 2 on the integral of, of 1 over u du, because 3x squared dx is our du, and x cubed plus 5 is u. Okay, so I'm going to substitute in what I can for what I can. All right, so now this is just going to be negative 2. We've seen the integral of 1 over x, or 1 over u, is just the ln of that. Let's see, the ln of u plus c. So really it is negative 2 ln of, what would he say it was? X cubed plus 5 plus c. Okay, now here's the thing. When you integrate something and get an ln, you cannot take the natural log of a negative number. So every time that you do this, you're going to need to put absolute value bars around it. Okay? So really, we should have done that up here. That's going to be the absolute value of x. It's going to be the absolute value of x. Okay? So anytime we take the natural log, or sorry, anytime that we get a natural log in our answer, we are going to have to put absolute value bars around whatever's inside there, because you can't take the natural log of a negative number. All right? So let's look at another one. So here u is going to be the bottom, so e to the 2x minus 2. So that du, remember how we take the derivative of e? We're going to write it down, so e to the 2x times the derivative of the top thing, which is 2. Okay. So we have our u. Our du, we have the e to the 2x, but there's a 4 up here that I don't want. I want a 2. Okay? So I'm going to take out the 4. And I'm going to put in a 2, which means I'm going to divide by 2 on the outside. All right. Now everything's fixed. So this is 2 on the integral of 1 over u du, because 2e to the 2x dx is our du, so it all goes away. And 1 du is left in its spot. And e to the 2x minus 2 equals u, so I'm substituting u in for that. Okay? So if I take the integral here, it'll be 2 on the natural log of the absolute value of u plus c, which is 2 on the natural log of the absolute value of e to the 2x minus 2 plus c. And there's our answer. All right. If I went through that too fast, luckily you can just back up and watch it again. Okay? Last one. So we're going to let u be the bottom, so u equals x minus 3, which means that du is equal to 1 dx. Oh, this was nice because du is already written for us. Okay, we've already got our du there. We have our u and our du, but this one's a little bit different because it has these bounds. So remember what we do there is we plug them into our u. So u of 0 is negative 3, and u of 2 is negative 1. So this turns into the integral from negative 3 to negative 1 of 1 over u du. Okay, so if I integrate that, that's the natural log of the absolute value of u, and I'm going to do that from negative 3 to negative 1. So that's the natural log of the absolute value of negative 1 minus the natural log of the absolute value of negative 3, top minus bottom. So that's the natural log of 1 minus the natural log of 3, which is a perfectly fine answer. Okay? In the future, obviously not anymore in this class, but in the future, if this was on a multiple choice, like if you take calculus in college, I can almost guarantee you the answer would be the ln of 1 divided by 3. Okay? But those two things are equal. Remember, properties of logarithms say if I'm subtracting two things, I can put them on the inside of a single logarithm with division. All right, that's it. So I'll see you